You know, let us start alcohols, phenols and ethers. Chapter number 11, class 12. Alcohols are represented generally by R, O, H. R is alkyl group. Okay. Phenols are represented by, this is phenol actually. In phenols we study derivatives of phenol also. Ethers are represented by R, O, R, ROR. These two alkyl groups may or may not be same. If they are same, then they are called symmetrical ether or simple ether, or if they are not equal, then unsymmetrical ether and called. Now, now let us start alcohols. Reaction alcohols. Now let us start with classification. Classification of alcohols. Alcohols are classified on the basis of the carbon atoms to which OH is attached. So we have some different types of carbon atom. For example, like this. This carbon atom is attached to a single carbon atom. Such carbon atoms are called primary carbon atom. This is primary carbon atom. This is also primary carbon atom. This carbon atom is attached to how many carbon atoms? 2. So such carbon atoms are called secondary carbon atoms. And this carbon atom is attached to 3 carbon atoms. Therefore such carbon atoms are called tertiary carbon atoms. So if OH is attached to a primary carbon atom, then the alcohols are called primary alcohols. The first classification is primary alcohols. Primary alcohols. In primary alcohols, OH is attached to a primary carbon atom. Primary carbon atom. So let us give some examples. Suppose this is a carbon chain containing 2 carbon atoms, and these 2 carbon atoms are primary carbon atoms. So if OH is attached here, then this is an example of primary carbon atom, primary alcohol. Another example is, suppose I am taking this carbon chain of 4 carbon atoms. How many carbon atoms are primary here? 2 carbon atoms. This is primary carbon atom. This is also primary carbon atom, and OH is attached to this carbon atom. Then this is also a primary carbon atom. This is called ethanol. What is the IUPAC name of this compound? This carbon atom where OH is attached is numbered as 1, 2, 3, 4. So this is butane 1-ol, not butanol. This is butane 1-ol. You must mention 1 because OH can be attached here also. Okay, this is about primary alcohols. This has been asked in council. Wow. Hydrogen hydrogen means this will be a primary carbon atom as well. So money. Second classification is secondary alcohols. The OH is attached to a secondary carbon atom. This is the definition, simple. Just like that. Example. There must be minimum of 3 carbon atoms for secondary alcohol. This is a secondary carbon atom. Here OH is attached. This is an example of secondary alcohol. Okay, this is an example of secondary alcohol. Each carbon atom in cyclopentane is secondary carbon atom. So OH can be attached here, 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 anywhere. Okay, these are examples of secondary alcohols. Third, tertiary alcohols. Tertiary. Okay, OH is attached to a tertiary carbon atom. Tertiary carbon atom is that carbon atom to which 3 carbon atoms are directly attached. So we must make a tertiary carbon atom first. This is a tertiary carbon atom. Many carbon atoms can be attached here, no need. Okay, but this is a tertiary carbon atom and OH must be attached here. This is an example of tertiary alcohol. So let me complete their valencies with hydrogen 2, 3. How will you name this compound?
1, 2, 3.
This is our main chain. This is our principal functional group. Methyl is attached as a side chain. Numbering must be started from this carbon atom. 1, 2, 3, 4, 5. So 2-methyl pentane 2-ol. This must be the name. Okay, and in cyclic chain also we can make tertiary alcohol like this. Suppose this is cyclopentane, right? So I need to make one of the carbon atoms as the tertiary. So I must attach a carbon here. Then this carbon atom becomes a tertiary carbon atom and the OH is attached here. How will you name this compound? This is 1, 2, 3, 4, 5. So its name will be 1-methyl cyclopentane. After removing E, 1-ol. This is the IUPAC. Note down. Okay, third types of alcohol is, fourth type is vinyl alcohol. Vinyl alcohol. In vinyl alcohols, OH is attached to a double bonded carbon atom. Double bonded carbon atom. Other than benzene, if OH is attached to benzene directly, then that becomes phenol. This is other than benzene. Okay, other than benzene. So let me give one example of vinyl alcohol. Suppose I am taking this chain. This is CH3, CH, double bond CH. These 2 carbon atoms are called vinyl carbon atoms. So if OH is attached to this carbon atom, vinyl, then this becomes a vinyl alcohol. This is vinyl alcohol. Okay. Fifth type is allyl alcohols. Allyl alcohols are those alcohols in which that is vinyl. This one is allyl. In allyl alcohols, OH is attached to a carbon atom, sp3 hybridized carbon atom, to a sp3 to sp3 hybridized hybridized carbon atom which is directly attached to a double bonded carbon atom. Double bonded carbon atom. Let me give one example of allyl carbon atom first, then we'll convert that into allyl alcohol. This is carbon-carbon double bond, and this is the carbon atom which is directly attached to this double bonded carbon atom, and this must be sp3 hybridized. Then if OH is attached to this carbon atom, then this becomes an allyl alcohol. Complete its valency like this. This is an example of allyl alcohol. Let me give another example of allyl alcohol. This is a double bond. To this double bonded carbon atom, this carbon atom is attached, right? And if OH is attached to this carbon atom, then this becomes an allyl alcohol, or you can say allylic or allyl. Last one is benzyl alcohol. Benzyl alcohol. What is benzyl alcohol? Benzyl carbon atom da OH tapko da basdena. Gandarba. Benzyl carbon atom is that carbon atom which is directly attached to benzene ring. Here OH is attached to the carbon atom which is directly attached to benzene ring. Attached to benzene ring. Okay, let me give one example. This is benzene, and this is the carbon atom which is directly attached to benzene ring. This carbon atom is a benzyl carbon atom, and OH must be attached here. This becomes an example of benzyl alcohol. Another example of benzyl alcohol is, this is benzyl carbon atom. To this carbon atom many carbon atoms can be attached, no need, and OH must be attached to this carbon atom. This is an example of benzyl alcohol. This is primary benzyl alcohol. This is secondary benzyl alcohol. Okay, we can make a tertiary benzyl alcohol also. Okay, now let me give one more alcohol which is, vicinal diol. Vicinal diol. Here two OH groups are attached to two adjacent means thangnaba, or you can say consecutive adjacent carbon atom. Let me give one example. This is two adjacent carbon atoms, and OH is attached here and here, and this becomes an example of vicinal diol, like this. This is called ethylene glycol. Common name, ethylene glycol. What will be the IUPAC name of this compound? IUPAC name of this compound?
Okay.
Yes. Is not the IUPAC name. Is the Hindi name of mango. Is Hindi. Ethane. This is the chain. So its name, IUPAC name will be ethane without removing this E. 1,2-diol. This is the IUPAC name. No doubt. Okay, IUPAC name or you can say nomenclature of alcohols. Let us take some examples. Let us name this compound first. Principal functional group is OH. OH is the principal functional group. This is our chain. Numbering must be started from left or right? No, right. 1, 2, 3. So 3 chloro prop in, 1 in, 2 all. This is the IUPAC name. 3 chloro prop 1 in, 2 all. Okay, let us take another example of alcohol. This is an alcohol. I am attaching methyl here, and here I am attaching what? Br. Okay. So name this compound. Numbering must be started from left side. Okay. 1, 2, 3, 4, 5, 6. So this is our principal functional group. 2 bromo, 5 methyl, then hex, in, 3 in, 3 in, 3 all. This is an example of secondary alcohol and a vinyl alcohol. Vinyl alcohol because OH is attached to a double bonded carbon atom. Okay, let us name this compound. This is double bond. This is OH. This is Cl. Okay, no pump throw them. And where? Double bond na ba? Makhadra mathakdra. Name this compound. 1 must be given to this carbon atom. Okay. 2 because OH is attached, and this is our principal functional group. That's why. 1, 2, 3, 4, 5, 6. So its name is 6 chloro, 3 methyl, not methane. 3 methyl. Where is 3? 3 methyl. Then cyclo, hex, 2 in, 1 all. This is the name. Okay. How will you name these two compounds in IUPAC nomenclature? This is an example of alcohol, not phenol. Okay. Phenol is when OH is attached directly to benzene ring. How will you name these two compounds? Tell me. This is our chain. Okay. This is benzyl alcohol in common name. And to this main chain of one carbon atom only, phenyl will be treated as a side chain. And if phenyl is not there, then this is methanol. Okay. CH3 OH is methanol. This is ethanol. This is ethanol. Okay. This is the derivative of methanol. This is the derivative of ethanol. Right. So its name will be phenyl methanol. Okay, this is our chain. Numbering must be done from this carbon atom, and phenyl is attached to the first carbon atom. One phenyl. Here one phenyl is must. Okay, one is compulsory. One phenyl, then you can write ethanol. Right. Let me give another example.
4, 5.
Name this compound. This is called, gasoline in Manipuri.
Glycerin.
This is glycerin, okay, and also called glycerol in common name. This is yes, gasoline. Gasoline in Manipuri common name. Gasoline. 1, 2, 3. Yes. Propane. Without removing this E, if more than one functional group is attached, is present in the chain, then this E is not removed. Remember, propane, that is the rule, because that's the reason. 1, 2, 3, triol. This is glycerol. Glycerol in common name.
Glycerin.
Gasoline in Manipuri,
Kerosene.
also called glycerin. Note down. Yare, sayan ba tawro si ko? Common name, IUPAC name yam tawro si.
Tetap sih, sir.
Nah, yare. Siapa mestinya lo? In preparation of alcohols, let us take from first preparation from alkene. We can prepare alcohols from alkenes. Okay. Suppose this is an alkene, and to this we add water in some conditions, and different names are there, different name reactions are there. OH and the H will be added like this. And if the alkene is unsymmetrical alkene, then some rules must be followed. Okay. Here we do not know this, as these groups are unknown. Okay. This is just an alkene. Can be symmetrical or unsymmetrical. Hydrogen is attached here and OH is attached here. This is alcohol. So let me give one simple example. This is an alkene which is called ethene, and if water is added in presence of an acid, then hydrogen will be attached here, OH will be attached here. This is hydration of alkene to form alcohols. We get CH3, CH2, OH, ethanol. This is ethene and this is ethanol. Okay. Now, if the alkene is unsymmetrical, then we must follow some rules. The first rule is, this is not actually the rule, this is acidic. Let me write this: acidic hydrolysis. Water is added in presence of an acid to an alkene, and if that alkene is unsymmetrical, then Markovnikov's rule will be followed. Okay. Addition of water will take place according to Markovnikov's rule. So when an unsymmetrical alkene is reacted with water in presence of an acid, addition of water takes place according to Markovnikov's rule. Markovnikov's rule. Let me give one example. CH3 CH double bond CH2. This is an unsymmetrical alkene and water is added in presence of an acid. This can be H2SO4 HCl. Okay, so this is partial positive, this is partial negative, and according to Markovnikov's rule, negative part which is OH here will be added to that carbon atom having lesser number of hydrogen atom, and the hydrogen will be added to this carbon atom. So we will get CH3 CHOH, and this will be single bond. This is our CH3. This is propane to all. This will be our major product. And there is another rule, hydroboration oxidation. So first note down this. Let me give another example because I have a space here. This is double bond. Here methyl is attached. This can be written combined like this: H3O plus, H2O plus, H plus. This becomes H3O plus. Okay, so the product will be this. Okay, this is our 1-methyl cyclopentane 1-ol. Okay, let us end this lecture here for today.